All right, here we go. It says the Hangout on air is live, so it must be 2 hours UTC. And once again, we're gathering together here for another live stream of Astronomy Daily Live. So cheers, everybody. Hope everybody's doing well. Bobby on the panel. What's going on, Bobby?
Nothing much about the app loaded so I can have chat.
Cool, very cool. Yeah, it was just sort of a lazy day here. So I see that Tom is in the chat. Daniel's back. Hey there, Daniel. Atta's in the chat. Uncle Bill painting the chat yellow. So hey, come on in. Come on in. Yeah, I was gonna. There was a chance of doing a star party tonight for some coworkers and friends, and it's pretty cloudy here. Pretty cloudy. So that has been canceled for today. I'll try again tomorrow. So, there is a possibility that the live stream won't be happening tomorrow. But we will have to see. We will have to see. Everybody live long and prosper. As a kid, right, I practiced this, right? So I could just do it, right? Yeah, there you go, Bobby. You're showing your true nerd if you can do it with both hands on call, right? In that sorry, in that one Star Trek episode where Spock went back to Vulcan, to meet his wife. The sort of the lady in charge. I think her name was T'Pring. Is it T'Pring? Um, I guess the actress, right? She couldn't do that, right? She couldn't, but she had to, right? Because she was a Vulcan. I mean, she was like the Vulcan. Um, and so I guess what the actress did is, they just showed a headshot, right? And down here in her lap, with her left hand, right, she spread her fingers apart, right, and held it. And and then yeah, and then when the time came, she lifted her hand, and I mean, it's only for a few seconds, and if you look carefully at her hand, it's like really stressed. She's holding it hard. Yeah, so she couldn't do it. Uh, um, yeah, well, Leonard Nimoy and William Shatner are both Jewish. So yeah, I think there was actually a lot of Jewish symbolism um, put into Star Trek, and that's very very cool. Whatever works, right? Uh, so yeah. Um, so so Tom, after the live stream last night, I'm like, what am I going to do here? What am I going to do? What am I going to do? Oh, I know what I'm going to do. I'm going to go and watch Assignment Earth, uh, the Star Trek episode where they go back in time, and they oh, I forget exactly what the term was. Hold on one second. I know somebody who might remember the exact term. It's four words. Hold on just a second. I'm gonna go ask. Hold on. All right, that was a fail. So yeah, can't remember exactly what they called it, but it was in like the first 5 seconds of the show. Captain Kirk, says something, right, which has put them back in time and all that. It's a great episode though, and yeah, I think it's called assignment assignment Earth. Assignment Earth. So yeah, very, very cool. Very, very cool. All right, well, hold hold on.
I guess if it wasn't for Star Trek, I guess if it wasn't for Star Trek being the most popular and stuff, it wouldn't have that made any more room for great sci-fi shows and stuff, like even more Star Trek and stuff.
Okay, all right, I've got it here. Thank you. All right, so I've got it here. What he says is that Captain's log using the light speed breakaway factor, the Enterprise has moved back through time to the 20th century. So they call it the light speed breakaway factor. And that's all they say about that. That's all they say. But that was enough, right? That was enough of a hook to be able to do something about it in Star Trek 4, right? So very, very cool. Pretty awesome. Pretty awesome. Yeah. Okay. T'Pring was his wife. It was T'Pau. T'Pau that was the elder. I think they described her as all of Vulcan in one package. So cheers to Vulcans. So hope everybody's doing well. This is wow. This is the 18th of August, 2018 at 2:08 UTC. So yeah, hope everybody's doing well out there in the universe and the world. Everything's good here.
Yeah,
Nothing... Yeah, go ahead, Bobby.
Just out of curiosity, I found these Star Trek movies on Netflix. I wonder if those movies are also available on, let's say, like Amazon Prime.
I don't know. That's a good question. Um, yeah, I'll have to look around a little bit. I'm thinking that maybe some of those might be, maybe not all of them though. And I have to admit that some of the Star Trek movies I'm not too much of a fan of. Yeah, the earlier ones were okay, and a couple of the later ones were pretty good. But yeah, yeah, I'm not exactly sure. I probably need to give a couple of those another try. But really after Star Trek 4, it at least in my opinion, right? It just took a nosedive. So when they introduced the TNG crew, there was the one that they call it First Contact. That one was moderately okay. The other one that I really, really liked was Generations. Generations was pretty good. Yeah, that one I think probably out of sort of the newer ones, that have come along after Star Trek 4, which, Star Trek 4 was sort of the end of the series that started with Star Trek 2, right? The Wrath of Khan, and then the Search for Spock, and then the Voyage Home. Those three are sort of, all part of the same story. Star Trek 1, I think, stood on its own, and as I said, pretty much, at least in my opinion, everything after 4 was just, sort of took a nosedive. But as I said, First Contact was pretty good. Generations was pretty good. I mean, how many are there now? I don't know. Don't know. Okay, cool.
Amazon Prime right now, Cosmic. I am now seeing they got Star Trek movies. They got the regular edition, and then they got like the director's cut. So I've been searching around the search engine on my Roku, and I found some of them right now.
Oh, very cool. Very cool. Yeah, I'll have to take a look because, every single Monday at 0 hours UTC, I do a Monday midnight movie, and I'm always looking for interesting things, and I like the old sci-fi, at least some of them. We watched one last week called The Cosmic Man, and it was pretty bad, but a lot of those are like that, and maybe if I can find a Star Trek, I haven't seen Generations or First Contact in a little while, so maybe that. The movie that I'm really itching to see is either Tron, the original Tron, or the Andromeda Strain, the original one of those.
Topic about
Yep.
the Star Trek movies.
Yep.
If you subscribe with Stars with the Prime and stuff, you might be able to try something like that. So
Okay.
you gotta use Stars in order to do something like that. Otherwise, for around $4, you can rent the movie. For $14, you can buy the movie.
Right. Yeah. All right. Well, I'll poke around, see what's there. Yeah, I tried uploading a digital version of The Day the Earth Stood Still, and even before it was done uploading, I got a message from YouTube saying, no, 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 no. Yeah, Tom, I liked, in a very, very, very rare kind of a thing, I definitely liked the book, and I definitely liked the movie. I like them both, and that is pretty rare. They did a pretty good job with the movie, I thought. So the old one, there's a new one out too. Well, newish, right? I mean, it came out in the last 10 years or so. So yeah. All right, well, cool. Let's see. It's 2:14, and let's see what direction. The only problem with this kind of live stream and this kind of subject is narrowing down what to talk about, as opposed to it's like, there's nothing to talk about. I've got the opposite problem. Yeah, I think one of the things that I was interested actually in hearing from everyone here is what topic in astronomy sort of has you, like most confused, most perplexed? What can't you really wrap your head around? And I was thinking about that too, and got to admit that um, I don't know if I can really answer that, because yeah, well, I guess I really don't have an explanation for why I can't answer that. I mean, I guess, again, there's so much, um, and for me at least, most of the concepts I can uh, wrap my head around. Okay, so dark matter, yeah, yeah. Um, let's say, you know, uh, all this dark matter, dark energy thing. Those names, I think, were really poorly chosen, because what that really is sort of, we have no explanation at all. So let's just call it something, and that that phrase is probably one, that and black hole, right? It's just it's it's like uh, the worst term ever, because of the connotation, right? Dark matter, uh, you know, uh, those two words, sort of imply that there's something physical that can't be seen. And mm, no, I mean, we're seeing, we're making observations, and we're seeing the effect of something, but whether it's, actual stuff, or whether it's something else, right? Uh, you know, some dynamic effect. Uh, you know, don't don't discount, uh, you know, other forces being involved. Um, be it like electromagnetic. Maybe there are other things that we just don't know anything about at all, right? So I mean, it doesn't have to see dark matter, dark energy. As I say, there's an implication there. There's sort of a connotation there that that don't can't really say for sure, for sure. But uh, so yeah, I definitely can wrap my head around that to a certain extent. I just don't like what they're being called. Now, do I have any kind of better term? No. I just don't like that one. Okay, so here's Uncle Bill's greatest confusion: string theory. Yeah. My thoughts on string theory is that uh, it's really, really, really easy to get caught up in mathematics. With mathematics, you can pretty much do anything at all. So yeah, I think for a little while there, a lot of astronomers and physicists and everything were sort of getting swooped up in the mathematics, and I think it sort of seems to me that they are coming out of that. And I mean, when I first heard that too, that threw up. I mean, I'm a skeptic anyway, right? But that threw up just huge red flags. It's like, whoa, 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 whoa. Even and Uncle Bill, you mentioned this twice. This idea of higher dimensions. Well, in mathematics, the word dimension has a pretty specific term. It means a particular thing, and that is basically parameters, right? So if you have 10 parameters in some kind of mathematical expression, well, you have 10 dimensions. But that's not what the physicists think, right? The physicists and astronomers, when they talk about dimensions, they're talking about physical dimensions, right? So, and this is all math speak, right? But we start with a point, right? And then we go to a line, and that creates a one-dimensional object is a line, right? Zero-dimensional object is a point. One-dimensional object is a line, right? And then if you move 90 degrees to that, 90 physical degrees to that, you get a plane, which is a two-dimensional object. Then if you take that plane and move 90 degrees to that, right, you get a cube. And then the idea is that if you were to move 90 degrees to that, you would get a fourth dimensional object, and then you could move 90 degrees to that and get a fifth and a sixth, and just on and on and on. I mean, that can go on forever, right? So that's why I say, I mean, that's an interesting mathematical tool, but there are a lot of mathematical tools that are used as such. Take, for instance, the Fourier transform, right? Fourier transform is a mathematical tool that can be used to look at things in a different way, and that's all it really is. It's just a change in perspective. And so, the same thing can sort of be applied to this, multi-physical dimension idea. Is that it isn't as if there are more physical dimensions. It's just that those are nice tools to use to sort of change your perspective on what you've already got. So, yeah. It's I really think that we're in an age in science where I'm thinking, I really am. I'm thinking that a revolution is right around the corner, and meaning that maybe in the next 50 to 100 years, our perspective is going to change on things, and it's going to be bigger than relativity. It's going to be on the order of Newtonian. So Newtonian, the Newtonian concept was a big deal, right? Because we basically went from it's some kind of magical thing. The motions of the planets, say, is just some kind of magical thing. They go along on these crystalline spheres, and you know, there's all kinds of gods and all of that, right? Sort of a mystical kind of a thing. Uh, and then Mr. Newton, he comes along, and you know, he definitely changed the perspective on things, and that created quite a revolution. That you know, to this day, you know, those concepts are used, right? You know, in order to move all the spacecraft around, we use Newton's laws. Newton's laws, um, and you know, we have to correct a little bit because Newton wasn't exactly right, um, and you know, that not quite right caused the revolution that was relativity. And I'm just sort of thinking that, you know, maybe you know, we're running up against uh, some pretty harsh walls, right? And instead of trying to, well, and I mean, this isn't quite fair because I think a lot of people are trying to understand what's happening um, in terms of you know, this idea of dark matter, dark energy, trying to understand exactly what that is. Um, but you know, I think we're smashing ourselves up against a brick wall, and what it's going to take is a change in perspective. Um, what that exactly is yet, don't know. But as I said, I think if we stay curious and skeptical and open-minded, I think I think we will come out with a new perspective that is going to revolutionize our thinking. Now, will that be right? Will that be, you know, what's going on? Uh, um, at least according to history, no, that's probably not right either. But maybe it'll help us move in the right direction or so. Um, yeah, Uncle Bill, I think when at least my understanding with string theory is that they are talking about actual physical dimensions, right? 10 or 11 of them, in order to make all of this work. And yeah, I don't know. It's um, I don't know. That to me is just sort of a red flag. It seems, you know, I mean, we want to find simple explanations, and you know, I try not to fall for that because oftentimes, you know, I'm sort of thinking that, you know, maybe there isn't a really simple explanation. So you know, just because it's complicated, I'm not going to throw it out, right? But it seems to me that, as I said, you know, uh, at least the string theorists seem to be caught up in the mathematics a little bit too much, and you know, uh, that's a really interesting place to be, but I just, it seems like they're a little stuck too. At least, you know, that's my understanding. So yeah. Let's see. So Tom is talking about the Higgs field, field theory in general. Yeah. That's uh that's an interesting one too. You know, because you're basically talking about, you know, like action at a distance. and you know, it doesn't indeed seem as though we live in this universe of fields, right, where we have like electrical fields, gravitational fields, um, and you know, these fields are these things, right? That yeah. So I agree with you, Tom. That, you know, the whole idea of fields is sort of a hard thing to wrap your head around, and I actually think that um, Einstein in this case sort of, and I don't know if it was exactly him or if it was his contemporaries or later on, you know, that came up with this idea of this space-time fabric, right? This structure, and the shape of that fabric sort of describes these fields, like a gravitational field, right? I don't know if that's the right way to think about that or not, as a, again, as sort of a physical thing. I'm Yeah, I don't know. I don't know. So yeah, that's a good one. That's a good one for sure. So cheers to field theory. And again, you know, I mean, one can easily get lost in that too, in terms of mathematics. So mathematics is like a sandbox, right? It's a great place to play, but um, yeah, I don't know. Sometimes it's a bit much. So cheers anyway to field theory. So is there anything, Bobby, that sort of boggles your mind in terms of astronomical stuff?
Not much really. Um,
I know
no,
that,
not much except I caught a piracy on shortwave.
yeah, I know a lot of people, you know, have, um, at least beginners, they sort of have a hard time with these big numbers, right? You know, distances and speeds and all of that. That's and you know, what astronomers have done over the years is, you know, tried to simplify those kinds of things, right? So, like the idea of a light year, right, which is the distance that a photon of light will travel in a year, and it's something like 6 trillion miles, right? Well, you know, astronomers don't want to talk about 6 trillion miles all the time, so they say one, one light year, um, and you know that that allows that allows us to sort of, you know, be able to consume that in sort of an easier way, and but then, of course, you know, once we had the idea of a light year and we started looking around and measuring, you know, the distances to things, we very rapidly realized that even the closest, excuse me, um, even the closest stars to us are like 4 light years away, right? And you know, the distance to the center of the galaxy is something like 20 or 30,000 light years away, and then, you know, the distance to the closest galaxy is like 2 million light years away. So, you know, even the idea of a light year, uh, you know, just seemed to be way too much, right? So then we started compressing things and talking about the parsec, and you know, the kiloparsec and the megaparsec. Um, yeah, yep, exactly, Uncle Bill.
Now, I did say you did do a nice pic of the monsoon on the Discord.
Oh, the which one are you talking about?
On the Discord, you did like a nice pic of the monsoon.
Oh, yeah, yeah, yeah. I just took that a couple days ago too. You want to? We can look at that really quick. Yeah, I really like the monsoons. For sure. Let's take a quick look at that, and then we can sort of move on to other things here. Let me pull up my Discord server. If you guys didn't see this, I'll show it off here a little bit. And this was just taken with my smartphone, so there's nothing extraordinary about the taking of this photo. Yeah, there it is. It was just kind of cool to see the whole thing, right? So there is the top looming over everything, and then you got this. I mean, just this really amazing blue, right? This electric blue here, and then of course the storm or the rain below. So yeah, pretty extraordinary. Just nice color, a nice blue color there. So yeah, I'm always amazed, but I just sort of like this because I could see the whole thing, and I mean that was shooting almost straight up, right? And it was actually making like a little hole here. See how the upper clouds were sort of moving away? Yeah, so it was actually making a hole up there in the clouds. So yeah, pretty intense. Pretty intense. Yeah, I took this, I don't know, maybe a week ago or so. It actually says here in the thing, so. Oh, okay, wow, that was like almost a month ago. Okay, so July 19th, it says. Oh, okay, very cool. At 5:19 in the afternoon here. So yeah, pretty cool. All right, well, I think let's do a quick constellation of the day. I was sort of getting set up to do that anyway. I was already over at random.org, and what I'm also going to do is I'm going to let me check my chat really quick. Yeah, Atta, I keep repeating what Carl Sagan said, and I'm paraphrasing, but it's basically, if we don't destroy ourselves, we're gonna have a great old time. And my vote is, let's have a great old time. It seems to me that the things that at least nations fight over, it's just I don't necessarily think that they're sort of following the will of the people. I think for the most part people really don't care. Their concerns are much more local, and we're always going to fight and disagree and stuff. I think that's sort of the nature of things, but we don't have to be so serious. We just don't. I mean, if you don't like something, just stay away from it. You don't have to destroy it. All right, so there are 88 constellations up in the sky, and I'm going to get over here and get my list of constellations pulled up. I've got an alphabetical list of all 88 of them. So what we'll do is we'll let random.org choose our constellation here. So you ready? Here we go. Bam. Okay, number 49. So now I'm going to go to line number 49 here. 49. Libra. Libra. Constellation Libra.
That's gonna be a zodiac one.
That is a zodiacal constellation for sure. I've got a story about Libra. So, and I think I've probably told this story before, but I'll tell it again just for fun. So, when I first got into observing the sky, I had a cheap old refractor telescope. I think it was from Sears or something, and I mean it was a refractor. It probably had a, what is that, like a 40 millimeter lens, maybe a 50. It's probably more like a 40 or so. Big long tube, that long or so. Just really bad, really bad. And so at the time I was sort of interested in looking at binary stars. So I looked at lists of binary stars and noticed that Alpha Librae, also known as Newbie, was a binary star. And it was also, really bright. Being alpha in the constellation of Libra meant that it was probably the brightest star in that constellation. So I'd be able to see it, right? And it was a binary star. Well, what I had heard about binary stars, right, is that it's two stars, and one star is sort of the primary, and the other star is the secondary, and the secondary actually goes around the primary, right, in some kind of an orbit. And it's like, well, that's very cool, right? So I proceeded to begin observing Alpha Librae, Newbie, for a number of nights, right? Probably spread over weeks or months, right? And every single observation, I would draw, where those two stars were, and it became very clear to me that for sure that secondary star was actually moving relative to the primary star. And wow, this is really amazing, right? This is very cool. I can actually see that star moving, which is pretty cool, right? Thought it was pretty cool. So, but after a couple of months of this, I was looking at my drawings, and I was looking at it, through this scope, and I'm like, well, is it moving or isn't it? I mean, at first it's like, oh yeah, I mean, I can definitely see it there. But after a couple of months, I'm like, I really don't know. So it was during that time, actually, that I had picked up the 3-volume set of Burnham's Celestial Handbook. And what I did is I went to the entry for Libra, and I looked up Alpha Librae, because I knew, of course, it was a binary star, and I also knew that Burnham's would, explain it a little bit more, and so I could understand it a little bit more. And so I'm going to go grab that book right now. Hold on. All right, so I grabbed this actual book. This is the real thing. I was 10 or 11 years old, right? And I went to Libra. So Burnham's is organized by constellation in an alphabetical order. So I went to Libra, just like I'm doing now, and I looked up Alpha Librae, Zubin El Ganubi, right there. And what I found, where did I see that? Of course, now I'm not going to be able to find what I was looking for. Yeah, see, I was reading all kinds of interesting things, right, about Alpha Librae, 65 light years away. 25 times brighter than the sun. Okay. They're calling it the field glass companion, right? The field glass companion, 231 arc seconds from the primary star. Actually has a different name, right? It's number 8. Magnitude 5.16. But it says that despite the wide separation, the two stars show the same proper motion, and undoubtedly form a true physical pair with a projected separation of 4,800 AU. And that's exactly what that says in the second paragraph there. Right? Can you read that all right? Probably not all that well. So I took that and ran with it, right? Ran with it, and somewhere I thought they talked about, okay, right. So this was the confusing part, is that then they changed, right? They changed a little bit and started talking about just the primary star, just Alpha, right? So they talked about Alpha Librae, right? And then the star next to it, 8 Librae, which seemed to be a physical pair. Then they went back to Alpha Librae and said that it was a spectroscopic binary with separated by about 0.01 arc seconds, right? 10 milliarc seconds, which at the time I didn't understand, right? It's like, okay, I'm not quite sure what that means. But it had an orbital period of 20 days, right? So I saw that, and I'm like, I'm seeing this star orbiting this other star. And yes, indeed, every 20 days. Well, I kept observing this, and it really didn't look like it was moving, right? It's like, okay, you know, over the course of 20 days, I should see that thing go all the way around once, right? Wasn't seeing that. It wasn't moving. You know, I was seeing it moving, right? But I wasn't seeing it moving at that fast. So I'm like, what is going on? What is going on? So somewhere along the line, and I thought it was in Burnham's, but I guess not. I guess not. Somewhere along the line, I did learn that that it probably actually was or is a binary system, but it has an orbital period of something like, I want to say like 14,000 years or something like that. So, you know, all of my excitement about you know, thinking that I actually saw this star moving was just like completely dashed, right? Just completely dashed. And it's like, you know, so now every single time I see that star, I am brought back to that time when I was observing it, and you know, it's like, man, that thing is moving, right? No, it wasn't. It wasn't. All right, let's take a look at Libra in a little bit more detail. I'm going to share my screen again. So yeah, this is one of the constellations of the zodiac, which in terms of astronomical things, it's all that means is that the ecliptic, the plane of the solar system, the plane that more or less every single planet follows as it orbits the sun, moves along this path, and that line, of course, is going to go through a number of constellations, and one of the constellations it goes through is Libra. So Libra is the scales, if I remember right. Yeah. So let's take a little closer look here at the map. I'm gonna put my chat up over here too, just so I. And look, Uncle Bill, I actually changed it to live chat. How about that? Let's see. Daniel, you're yeah. Things do get just more and more confusing. I got to agree with you there, because yeah, the more we look, the more we see, and yeah, it just gets you know, this is a fractal universe, right? I mean, it's pretty, and I think it's becoming more and more clear all the time that you know, at any scale, things sort of look exactly the same. So you know, if you look at the very, very small, you're seeing things that look exactly the same on the very, very large scales. And this fractal nature isn't limited to physical things. In terms of processes, right? I think that this universe is a process fractal as well. It feeds back into itself. So yeah, it's a pretty amazing place. So cheers to confusion. All right, well, here we are in the constellation of Libra, and the entire constellation is south of the celestial equator. Right here is the celestial equator, a declination of 0 degrees, and all of that is south. It's a pretty big constellation, right? 30 degrees north and south, and maybe not quite that far east and west. Every hour of right ascension is 15 degrees. So we're going from what, about 1420, 1430 over to 16. So, it's an hour and a half-ish or so. So, 20, 22, 25 degrees or so east and west, 30 degrees north and south. More or less a square, more or less. And yeah, you basically have two bright stars, alpha and beta. And here's Zubin-El Ganubi here. Here's Zubin-esh Shamali. So these are Middle Eastern words. A lot of the star names are based on Middle Eastern terms. So yeah, you've got some pretty interesting names there, for sure. Yeah, so there it is. We've got alpha, beta. Here's a gamma. Here's Omicron, Kappa, Theta. Yeah, I guess Delta here looks like it's a little open circle, which probably means it's a variable star. Probably a variable star. So I can actually look in Burnham's here and just take a quick look to see if Delta. Yeah. So Delta it's an eclipsing binary, similar to Algol, right? Similar to what Algol is doing. So yeah, maybe we can take a look at that a little bit more. So Delta, yeah, that's this guy here. Looks like he varies between about magnitude 4.8 and magnitude 6 over the course of a couple of days. So yeah, that's kind of cool. All right, well, let's see what else Wikipedia has to say about this, and then we can go from there. And if there's anything interesting that sort of grabs our eye, we can go from there. So yeah, Babylonian. Let's see the constellation itself. So at least according to this, there's 83 stars that are brighter than magnitude 6.5. So 6.5 is a little bit beyond what the human eye can see. Maybe in a really dark sky, and if you've got really good vision, you can see down to 6.5. I don't claim to be able to see to 6.5. I can definitely see down to 6th for sure, and that's typically what sort of the understanding is that we humans can see down to about 6th magnitude without any kind of aids. Let's see. Yeah, so even through binoculars, you can tell that Alpha Librae is what they're calling a multiple star system. So yeah, each of those 2 stars looks like they're probably binary stars too. Most of the stars in the sky, at least half of them, I would say even more than that, maybe 70% of all the stars in the sky are binary. in some way. So, you know, our sun, as far as we know, isn't a binary star, which is kind of rare, So let's see, Alpha Librae, yeah, magnitude 2.7, so pretty easy to see. 160 light years away. So Iota Librae, they're calling it a complex multiple star. Magnitude 4.5. Cool. So, of course, they found stars that have planets, supposed planets. 3 in this case around this guy. 2 unconfirmed. Cool. So it looks like, you know, if these planets are actually planets, maybe they're in a position to be candidates to be able to host life, and everybody's really excited about trying to find life elsewhere. So I'm not as excited. I think that's sort of a no-brainer, and I think it's just a matter of time. I'm going to be very excited, right, when we actually do find life, but I'm not going to be surprised at all. So there's a globular cluster there, NGC 5897. So I say let's look at delta first, and just sort of see what the astronomical community has learned about delta, and then maybe if we have a little bit of time, we can look at NGC 5897. But let's look at this variable star delta. ELTA. Is it Librae? I think it's like that. Yeah, eclipsing binary of Algol type. So yeah, this is just sort of the updated info on that. You got a position here in the sky, right ascension, declination, proper motion. So this is milli-arc seconds per year, and it looks like it's moving. Let's see, to the west in right ascension and south in declination. So that's why there's a negative here and a negative there. It's moving west and south. It looks like it's moving towards us at a pretty good clip, 38.7 kilometers per second. So that's just a relative motion, though, right? It isn't as if we are stationary and the star is moving towards us. It's just relative to us. It's moving towards us. Putting it another way, we're moving towards each other at that speed. I actually have a parallax on that too, 8.32 milliarc seconds. So with that number, we'd be able to figure out about how far away it is. I'm not going to do that though. So it's an A0 star, which is pretty big, pretty hot. Here's all the magnitudes. Looks like it's pretty consistent over a pretty broad band, right? This is going from very blue through to the infrared. It's pretty consistent, right? And that's sort of typical for these A stars. They emit pretty equally at all wavelengths. Vega, right? Star Vega is an A0 star and sort of exhibits the same thing. In fact, Vega is so consistent that we actually have defined Vega as magnitude 0, right? And we use that star to reference the magnitude of every other star in the sky. So here's a bunch of other names for it. It has, every star, every visible star, at least in the constellation, usually also has a number, right? So this one is not only known as Delta Librae, but it's also 19 Librae. But it also has a bunch of other names, which these are just, catalog names. It even has a Gaia Data Release 2 name, right? Just this big number. I wonder. I'm thinking that this number has some kind of a significance, but I have yet to look into that. Most of the names here, most of the numbers, just correspond to right ascension and declination, right? So 150058.0, that is the right ascension, right? More or less. And then a negative 083103, yeah, more or less, right ascension and declination. So I think a lot of astronomers, at least the ones that do podcasts, sort of, knock down these names. I don't. I think there's a lot of information there. But a lot of these are just, different kinds of surveys. So lots of references for sure. Let's look at the distances here. So they're talking about 120 parsecs. So a parsec is 3.26 light years. So what is that? 3.26 times, let's do 120.074. So what is that? 391.4 light years away. So right in the neighborhood, right in the neighborhood. Wow, they even have a measurement of its diameter. Right, that's impressive. Right, 2.74 million kilometers across. So they actually have a measurement of the diameter. I wonder how they got that. They've got a reference here. Kind of interested in seeing how they got that that size. Characterization of dusty debris disks. Newly identified debris disk at as many as 33 main sequence stars. Of these, 32 are within 100 parsecs of Earth. So why would they reference this paper in order to get a physical size? Let's dive into the paper really quick. See what's going on there. This is the curiosity part. Holy moly, look at this. 58 pages. Let's see. It's Delta Librae, Delta. That's not coming up. Ooh, that's not coming up either. It's got a IRAS name, right? Right? This was Iris and Hipparchus. So let's see, does it have an Iris name? Yeah, there's an Iris name. Probably has a Hipparchus name too. HIP, yeah. So let's look for the HIP number, 73473. 73473. So it's a triple system. That's what this is saying, at least. So there's a spectrum of Delta Librae. Kind of cool. Oh, let's pull this up a little bit more. So this is, oh, that's a little bit too big. So here's wavelength across here. So here's, we can basically see from, let's see, this would be 10,000 angstroms, 9,008, 76543. Okay, so we can, the visible wavelengths is more or less from about 4,000 angstroms to maybe about 7,000 angstroms. So 4, 5, 6, 7. So right in here is sort of the visible part. This is ultraviolet. This is infrared. And almost getting into the sub-millimeter, right? 100 microns is 0.1 millimeters. So yeah, you know, almost getting into the sub-millimeter range. So yeah, lots of absorption, lots of interesting things there. All right, let's keep going. Zoom out again here. Okay, so here we go. What have we got here? Okay, so this is describing what looks like solar radii, right? The radius of the star in solar radii, the temperature in Kelvin, the distance in parsecs. So that sort of disagrees with what we looked at before. I think they were saying like 120 parsecs, and these guys are saying 93.3. But here is a radius, at least. So 3.94 times the radius of our sun. So cool. Okay, it's actually there. There's actually some notes about that too, 2, 8, and 26. I don't know what the rest of this is. Age, 500 million years. A little bit of dust. Not quite sure what these other things are. Temperature of the dust, temperature of the star, radius of the dust in astronomical units. So it goes out 31 astronomical units. So just to put that in perspective, I think the orbit of Pluto is about 40 astronomical units. Maybe Neptune's about 30. Don't remember. All right, what other references do we have here? Okay, that's just Algol type stars. Okay, yeah, that was it. Okay, that's kind of cool. So let's see, pretty good agreement, I guess, with radial velocity. That one sort of stands out. Maybe a couple of these other ones, but you know, these are pretty old measurements, right? 1928, 1909, 1929, 1937. So, you know, depending on the techniques used, and the instrumentation that we had available, yeah. But it's looking like it's maybe about 40 kilometers a second or so. Proper motion, yeah, relatively good agreement there. Spectral types, pretty good agreement that it's an A0. Observation logs. I don't know what this is all about. Should we look? It's trying. While this is going, I'm going to check the chat really quick. Uncle Bill. Your sign's a Libra, which means you're a Virgo. Okay. I guess so. Daniel, I think they've calculated pi to several orders of magnitude, like 100. Well, yeah, wow. Now I'm not remembering. It's a huge number of decimal points, though. Huge. All right, this is not coming up, so just forget it. Just forget it. Let's see, what else is here? Looking at a bright star isn't going to be too interesting. Let's see if we can get a sense of the variability. I'd like to get a light curve on this thing, because it is a Algol type variable star. So let's see if we can get catalog and classification. That looks promising. What do you think about that? Should we try that one? I just like to get a light curve on this thing. Actually see what it looks like. Well, let's go there. May not be able to get too far with it this way. All right, it's not going to let us do it. You know, having to pay for papers that have already been paid for, pretty annoying. Let's see if archives can still. Sometimes it's just not listed there, but we can come up here and look for titles. Yeah, nope, that's not exactly the same one. So, well, all right, well, let's look for another one. Oh, we're starting to run over time here. Solution model. Looking for a light curve. I'm sort of surprised that we don't have any. Well, let's just sort of see where this goes. It does say plots. Yeah, that's just that thing, though. I'm going to close this. Is there a way to do that? No, I'm just going to have to fly through all of those. Display all measurements. I think that's what this is. Yeah, it's IUE. Okay, that's not going to help either. Ah, shoot. I'd like to get a little light curve on this thing. Well, you know, let's see if Wikipedia has anything. Variable star. Seeing anything interesting there? Yeah, not seeing anything specific. I would sure like to see a light curve. Definitely like to see a light curve. Well, I'll poke around. I don't think I want to take up any more of anyone's time here. So, I think for now, let's... Yeah. I'm getting the call. I'm getting the call. So, I've got to get off of this planet. It's too heavy. It's too heavy. I like to be a little lighter. So, I think it's about time to get out of here. So, thanks everybody for coming in, hanging in, looking at the constellation of Libra a little bit. There's a little bit more to explore, I think, with Libra. So maybe we'll pick this up again either tomorrow or the next day or something. Because let's. I like to dive into these a little bit more, and I don't think that we've looked at this quite enough yet. So let's leave that to another day. As I said, there's a possibility that tomorrow the live stream will not happen, but if it's anything like today, I will be here. So, but yeah, gonna have to sort of decide that in the last minute or so. So if I do cancel, I'll let you know. As I said, I'll try to make a video or something. I'll make a post over on Discord. I'll probably tweet it too. So, just keep your eyes open. If you don't hear anything at all, just assume that I am going to do a live stream and that it's cloudy here. But if it is clear, or the possibility of getting clear, I will be doing a star party for some coworkers and some friends. So the live stream will be canceled. But I would say right now that there's a 80 to 90% chance that I will be doing the live stream, that I will. So, all right. Well, for now, take care, everybody. Peace, cheers, and all that. And I will see you on the spin. Bye.
Later.